Hi everyone, we are from group 1. We would like to present you guys about topic 1. So for the topic 1, it's about introduction to computer and programming language. I'm FARZANA. I would like to present you guys for the chapter 1. That's about basic operation of a computer. So as you all know, computer is a device that can process data. Data contains a raw fact or unprocessed information. So computer also a electronic device that capable of performing computation and making logical decisions faster than human beings. So everything that we search in computer is faster than what we can get. So for computer, it's content for basic operation. For the first one, it's input. Second one is process. Third one is output, and the last one is storage. So for the input, computer accept data from users. So let's say we search for something. Computer will search anything that we want. After we put the input, computer will process and manipulate the data. So after the process, computer will produce the result, and the last one, computer will store the result that we search. So next is computer component. So for the computer component, we have software and hardware. So for the hardware, there is the part in physical computer system. For the first one is flash memory card reader. So this one, the function is to read or writing a flash memory card by the PC. Next one is DVD driver. This one is to read and write the CD or DVD. So next one is hard drive. It stores the program and most of data in computer. Next is system unit. System unit contains the CPU, memories, power supplies, disk drive, and all the internal hardware. Next is the monitor. So for the monitor, it display the visual information on its screen. Next one is printer. So printer is a part of computer that produce copies from computer output. Next is modem. So modem is the function is to connect the computer to the internet. Next is USB flash drive. So USB is used to store the document, digital photos, music, files, and other content that separate from PC data. Next one is flash memory card. So flash memory card used to store digital photos, mostly used to store the digital photos and music. Next is the mouse. So the function of mouse is to point object in monitor, copy the move, select words, and zoom in or zoom out. Next is CD and DVD. So CD and DVD deliver program or multimedia files that contain a large file. Next is USB port. USB ports is connect the external or USB flash drive. Next one is keyboard. Keyboard is to type instruction into computer to input device. The second last one is speaker. So speaker, the function is to produce audio output. And the last one is microphone. It captures spoken input.
On computer software side, they have two main things. One is system software. So basically, system software we refer to as operating system, a set of instruction or command that tell a computer what to do. So like what we have right now is Windows 11. Number 2 is application software. So basically, program that we provide service or solution to the user. For example, Microsoft Word to do word processing. Second, Microsoft PowerPoint to make a presentation. Okay, hardware inside CPU. Number 1 is CPU. What is CPU? CPU is a central processing unit. The CPU is the heart of the computing system, and the CPU performs basic arithmetic, logic, controlling and input or output operation specific by the instruction in the program. Number 2 is RAM, random access memory. What is random access memory? It used to store working data and machine code that computer needs to access quickly. Number 3, ROM. What is ROM? Read-only memory, a type of computer memory that holds information that can be used but not changed or added to. The content of this memory can only be read from but cannot be altered. Number 4 is CU, that we call control unit. They control input or output device, the arithmetic and logic unit ALU, and memory response to instruction. Number 5 is ALU. What is ALU? ALU is the path of performs mathematical and logical operation. Okay, so this is an example hardware inside CPU. Computer language. Computer language is a language that we use to computer. Machine language is basically a language which consists 0 and 1 or in binary. The computer only understand machine language. Okay, next is assembly language. Assembly language is a computer language that allows words and symbols to use in a unsophisticated manner to accomplish simple tasks. This is generally known as a low-level language. So we have a very short command like a load, like a store or add. Okay, so next is high-level language. High-level language is a programming language that use words and symbols to make program relatively easy to read and write. Example of high language is C++. Okay, this is a example 1 is a example of high level language. Okay, so next is IDE. IDE is integrated development environment. This is a software application that help programmer develop software code efficiently. Okay, so here is why we program. Computer is basically a programmable machine designed to follow instruction. For program is a instruction in computer memory to make it do something. And last, programmer, that person who writes instruction programs to make computer perform a task. And last thing, this is a example of IDE.
So we move ahead with chapter 2, which is problem solving techniques. In this chapter, we will cover a topic about system development methodology, program development, and basic problem solving techniques. So what is system development? Development is the process of designing, building, testing, and maintaining software system. It involves structured steps to ensure the system is efficient, reliable, and meets user needs. So next, the system development methodology has a four step, which is the critical process determines the overall quality and success of the program. Next, well-designed programs are efficient, error-free, and easy to maintain. Third, most programming projects are built using system development lifecycle, which is the short form is SDLC. And lastly, one of the popular development life cycle is known as the waterfall model. I will explain the waterfall model in the next page. Okay. So this is waterfall model. It one of the popular development life cycle. The waterfall model is a linear, step-by-step approach to software development. Each phase, which is has 6 phases, like requirement, design, coding, testing, and maintenance, must be complete before moving to the next step. Okay. Moving on to program development. Program development is a multi-step process that requires you understand the problem, design a solution, write the program, and test the program. Program design to determine how to take inputs and convert them into the output that have been specified in the program requirement statement. Later in the slide, I will show the example of the program problem. Okay, this is four basic problem solving technique, which is analyze, design, code, and test. First, we will analyze the problem and understand the problem. Second, design the algorithm to solve the problem. Third is code. Develop or write the program after we understand the problem. And lastly, test the program to see the program is works fine or not. So now we will try some problem example by including all the four basics problem solving steps. First, let's look at the problem first. So the problem is you work at a pet store and you need to convert the weight of pet food from kilograms to grams for customers. Write a program that performs the conversion and display the weight in grams. So there is a formula given, which is 1 kilogram equals to 1000 grams. So the first step is analyze, understand the problem, and highlight important clues. So in the question just now, the important clue is convert the weight of pet food from kilograms to grams for customer, which is we need to convert kilograms to grams for the customer, and write a program that perform the conversion. So the highlight in this question is perform the conversion and display the weight in grams, which mean we need to type the kilogram first, and then the program will display the weight in grams. So the formula is 1 kilogram equals to 1000 gram. So next step is design. Determine the input, process, and output. So the input is kilogram, which is that like in the question it state that the pet food is original weight in kilograms, so we need to convert to gram. So the input is kilogram. So the process is in the formula 1 kilogram equals to 1000 gram. So that's mean gram equals to kilogram times 1000. So the output will be the gram. So next we write the program. Like as you can see, the program I use C++, and then if you look at the bottom, it show that no issue found. So that means the coding is work perfectly. Okay, so next, last step is test the program. So after I run the program, it will display an CMD. And first, the program will ask me to enter the weight of pet food in kilograms. So I put 5, and then after I click enter, the program uh, will show the kilogram in grams. So like in this picture, it will show the 5 kg is equal to 5,000 grams. So like I said before, check for any syntax or runtime or logic errors, so the coding will be run perfectly. So that's for the chapter 2. I will pass to another group mate. Thank you so much.
Hello, my name is AFIF. My metric number is B1224107164 from class BRZ S1 and 1. And today I will present to you about chapter 3, Introduction to C. What we learn in this chapter is the basic structure of C programming, concepts of character set token, keyword, identifiers, operator punctuation, input output. Next is data type declaration and statement, input output function, and lastly operators, arithmetic, assignment, relational, logical. Here are the basic structure of a C program. First, we have the preprocessor directives. These are the lines that start with a hash symbol such as include stdio.h. Preprocessor directives are processed before the program is compiled. In this case, include stdio.h brings in the standard input and output library, which is essential for functions like printf. Essentially, preprocessor directives helps us include libraries or define constants. Next is the main function, in main. Every C program needs a main function because it acts as the entry point of the program. The in return type means this function must return an integer. Here we usually return 0, which indicates a successful program execution. Inside the main function, we have variable declarations. Like in number 5, this line declares an integer variable named number and assigns it a value of 5. Declaring variables lets the compiler know what kind of data we're working with, allowing it to allocate the right amount of memory. Moving on, we have executable statements. Here, printf, the number is %d\n number is used to display the value of number on the screen. Each statement in C ends with a semicolon, which tells the compiler that the instruction is complete. Finally, we reach the return statement, return 0. This line terminates the program and returns control to the operating system. By returning 0, we signal that the program executed successfully. Next, we're going to dive into some essential command output basics, specifically escape sequences. These are special characters used in programming to control text display and formatting. The first escape sequence we have is \t, known as the horizontal tab. It moves the cursor to the next tab stop in the output. For instance, using the code displayed in code will display A, then tab over to display B, and then see which it word separated by a tab. Next is \n, or new line. This is probably one of the most commonly used escape sequences. It moves the cursor to the beginning of the next line. For example, this code, hello will appear on one line and world on the next line. Then we have \v, the vertical tab, which moves the cursor to the next vertical tab stop. Using this code will display A, then vertically space down to B, and then down to C. The \quote escape sequence displays a double quote within a string. For instance, this code said, hello will print the sentence with quotation marks around hello as part of the output. The escape sequence \apostrophe is used to display an apostrophe. In this code, this helps include an apostrophe within the text without breaking the code. Next up is the question mark escape sequence, which is used to display a question marks. Using this code will print the sentence including a question mark. Finally, we have \. The backslash is skip sequence. This displays an actual backslash in the output. For example, printf, this is a backslash, will display a single backslash. Next, we have an audible alert. This escape sequence produces an alert sound, a simple beep, which can be used to grab the user's attention. In the example, this code will output the word alert followed by a beep. Next, we have \b or backspace. This moves the cursor back to one position, effectively erasing the previous character. For example, this code will display 1 to 4 by erasing the 3. The \r sequence is the carrier's return, which moves the cursor to the beginning of the current line. Using this code, we replace 1, 2, 3, 4, 5 with ABC on the same line as the cursor resets to the start. Then, we have \f, known as form feed. It moves the cursor to the next logical page, which is essentially useful in printers and older systems. For instance, this code will treat page 1 and page 2 as two separate pages. The \0 sequence is for the null character, which represents a zero value character. Is mainly used to terminate strings in languages like C. In the example, char string, only hello will be print because \0 stops the string. Next is \xh, which allows us to represent characters using their hexadecimal ASCII values. For example, this code prints letter A, set 0x41 is the ASCII code for A. Finally, we have \OOO, the octal character, which represents a character using its octal ASCII value. In this code, the octal 101 corresponds to the letter A. Here are the output results of the code that is mentioned in the recent slides. You can see the output above. Let's talk about the two foundational concepts in programming language: character sets and tokens. Understanding this will give us insight into how programming languages interpret different characters and symbols. Let's start with the character set. The character set is a collection of characters that a programming language recognizes. These characters are essential for forming words, numbers, and symbols. First, we have numbers, which range from 0 to 9. These are the basic numerical characters that programming languages use. Alphabetical characters, which include both lowercase a to z and uppercase a to z letters. These are used to form words and identifiers in code. Spacing includes white space characters, which are essential to separate words, operators, and other elements. Proper spacing makes code readable and well structured. Lastly, special characters like double comma, question mark, and exclamation mark play unique roles in programming languages. They are used for various operations, punctuations, and expressions. Now let's discuss tokens. A token is a collection of characters or a basic unit of a program that's parsed by the compiler or interpreters. Tokens represent keywords, identifiers, operators, and other syntax components. Reserved words, also known as keywords, are predefined words with special meanings. Example include if, while, and for. These cannot be used for anything else like naming variables. Identifiers are names that programmers give to elements in the code like variable names, function names, and constants. These names help me identify specific elements in the code. Punctuators include symbols like double comma and double dots. These are used to organize code structures such as separating statements or defining scope. Correction, the double dots is just single dots. Operators are symbols that represent operations like plus, minus, star, slash, and equal. They are essential for performing mathematical and logical operations in code. Lastly, we have literal strings, which represent constant values like hello world or ABC. Literal strings are used to represent specific values directly in the code. Next, we'll be discussing reserved words, also known as keywords, in the C and C++ programming languages. These are integral to understanding how we structure and write code in these languages. Let's start by understanding what reserved words are. Reserved words are predefined words that the language itself uses to define its syntax. They form the basic structure of our programs and have special meanings that the compiler understands. Because of their predefined roles, we can use these words as names for variables, function, or any other identifiers we define. Reserved words, keywords. First, we have the general concept of reserved words or keywords. These are essential in C and C++. Keywords are case sensitive and usually appear in lowercase. Their purpose is fixed by the language, and we as programmers cannot redefine them for any other use. The next is C and C++ reserved words. These words include things like in, return, if, else, and many more. Each of these keywords has a specific role. In is used to declare integer variables. Return is used to return a value from a function. If and else are used for conditional statements. Finally, we have C++ exclusive reserved words. These are the keywords that are exclusive to C++. These include words related to object-oriented programming and other advanced features. Class is used to define a class. Public, private, and protected are used to set access levels for class members. Namespace is used to define a scope that holds a set of identifiers. Mutable allows a member of an object to override the constants of the object. Let's take a look at the table on the slide. It's divided into two main categories, C and C++ reserved words and C++ exclusive reserved words. In the first category, we have the reserved words that are common to both C and C++. These include fundamental keywords such as auto, break, case, char, const, continue, default, do, double S, and others listed in this table. These words have special meanings in the language syntax and cannot be used as identifiers for variables, functions, or other user-defined items. The second category lists the reserved words that are exclusive to C++. These include more advanced features and object-oriented programming concepts such as AZAM, bool, catch, class, etc. These keywords enable more complex and powerful programming constructs that are not available in C. In conclusion, understanding and correctly using these reserved words is essential for effective programming in C++ and C. If we familiarize ourselves with these keywords to avoid syntax error to write more efficient code.
Hello everyone, my name is KARTHIGEYAN. My matrix number is B1224106 and 23. Okay, today I'm going to talk about what is identifiers. Some may ask, what's identifiers? What's that? It allows programmers to name data and objects and other objects in the program. It also can use any capital letter through A through Z, lowercase letters A through Z, digits 0 through 9, and also underscores. There are few rules to follow if you want to code in C. The rules are, first, the character must be alphabetic characters or underscore. It cannot contain spaces and cannot copy any other word combination that had been used. Because C language is very case sensitive. Lowercase of certain word, uppercase certain word, or the same word with underscore could be different meaning to it. Okay, next slide. This is how the few valid identifiers and invalid identifiers that we cannot use in C language. Okay, next we're going to talk about constant data value that cannot be changed during the execution of a program. There are few types of constant: integer constant, float constant. Number with decimal part are called character constant. Enclosed between two signal quotes, it is called string constant. A sequence of zeros or more characters enclosed in double quotes is called symbolic constant. It is defined constant and memory constant. Now we are going to talk about literal constant. It is unnamed constant used to specify data. If the data cannot be changed, we can simply code the data value itself to a in a statement. For example, B is could be a char literal. Digit 1 could be a numeric literal. If you want to put algebraic calculations, for example x plus 3, it's a numeric literal. Float and then dash string literals. Okay, returning to constant, we're going to talk about defined constant now. Defined constant is using the processor's command define. Like other processor commands, it is also prefaced with the pound sign placed in front of program for easy finding and changing. Example, hashtag define sales commission rate and etc. The way define works is that the expressions that follow the name, a digit, replace the name wherever it is found in the program, like search and replace command. Next is memory constant. C provides the capability to define a name constant where we can add the type qualifier constant before the definition. Type of qualifiers indicate that data cannot be changed and fix the content of the memory location. For example, constant float pi equals to 3.1416. Now we're going to talk about variables. Variables are named memory location that had a type such as integer or character and has a size which is inherited from here type. Each variable in programs must be declared and defined. When we create variables, the declaration gives them a symbolic name and definition, reserved memory for them. One-defined variables are used to hold the data that are required by the program for its operation. These are the few examples of variables. Before we start any variable, we need to put variable type and variable name to it. And these are the examples for it. Now, variable initialization. Initializer established in first value that the variable will contain. To initialize a variable when it's defined, the identifier is followed by an assignment operator, equal sign, and then its initializer, which is the value of the variation to have when the function starts. Example, in count equals to 0, in count sum equals to 0, only sum is initialized here. In count equals to 0 or sum, or in count 0 in sum 0. Now we are going to talk about punctuators. It is used for completing program structures, including square bracket, parentless bracket, and curly bracket, comma, and so on. Operators are C used a set of built-in operators. For example, plus sign, dash, and star, and columns. There are several classes of operators: arithmetic, relational, logical, and assignment. Now, we're going to talk about common programming errors. There are three common programming errors. One are syntax error, logic error, and runtime errors. Syntax error will occur when your code violates some or more grammar rules of C. It also can occur if you missing semicolon, if it's undeclared, it's variable missing, and it has braces. Next, logical error. It will happen if program follows a faulty algorithm. Usually do not cause runtime errors and do not display error message. Very difficult to detect though. And finally, we have runtime errors. It is detected and displayed by the computer during the execution of a program. It's illegal, or it can happen when there is an illegal operation such as dividing by 0, or the computer will stop executing a program if the runtime error occurred. Thank you very much.